So welcome back to your learning journey in the statistics and probability for data science. Now in this video, we are going to proceed ahead in a learning journey of EDA, that is exploratory data analysis. So we are now in the section 2 of our learning journey where we have completed the foundations of statistics, and currently we are in the unit of exploratory data analysis. Now in this unit, as part of this video, we will see how we can analyze the data, especially a single column at a time, and what are the ways that in which that we can analyze the data. As you know, this univariate data analysis is a third step, I would say, in exploratory data analysis. We'll start with data acquisition, we'll clean the data, and we will begin the univariate analysis where we can start analyzing single variable at a time. Now, in order to perform this univariate analysis on a data set, I've started by importing a basic data set, that's the iris data set. I've created a data frame. So this is how my data frame would look like. So I've created the data frame by loading the data set. Now we can start by exploring this data set by calling the dtypes attribute. So this will let us know the type of data that we have got on this data set. So all the data are belonging to the floating point numbers, and the target is in integer format, which means every value in my data set is in a numerical format, which means we don't have to worry about the data cleaning and data formatting. So we can also do one thing. I'll say info. So this will help me to validate whether we have any missing values. So we can see that we do not have any missing values in this data set. Now, when it comes to analyzing a single column at a time, whenever we are working, we generally prefer to create the visualization to get a better perspective about the data that we are working. In order to create the visualization, I'll start by importing the matplotlib library, then Seaborn. So these are the two libraries that I'll be using. Okay, then once I have imported the libraries, let's start by visualizing the data set. So here, this visualization methodology for univariate data helps us to understand some of the common properties of my data set. Along with that, it will help me to get a better perspective about the descriptive statistics as well. So these plots will actually help us in identifying what is the location of a value and what will be the position of its value. We can also understand its distribution as well as the dispersion, which are the core concepts which we have learned in our previous section. So when we think about the visualizing the data set single column at a time, we've got a variety of options. I'm going to take you through some of the commonly used methodologies which we use it for creation of plot and performing the univariate analysis. So one of the common way that we do it to perform the univariate analysis is univariate scatter plot. Now we'll create this univariate scatter plot whenever we just want to see how does the data point would look like. I mean, the values would look like along a specific axis. So the scatter plot is generally created for bivariate analysis, but if required, if I want to analyze a single column of numerical values, then we might use this scatter plot as well. So when I say creation of scatter plot for a univariate column, let us consider a scenario. Let us say I want to create a univariate analysis for the column of, let's say, petal width. So this is the column that I want to consider. So let's see how we can do that. Okay, so plt.scatter. So along the x-axis, I'm just going to say index in this case. Okay, so here for the column name, I'll mention as petal cm. Okay, this is how the column name would look like. Okay, there's an additional space. Okay, now I'll just say plt.show. So this is how the plot would look like. Okay, so we have the various values of petal width, and this is how the data is distributed. So one thing is pretty clear is that, okay, we have the values. Okay, it is varying between 1 to 2.5. That is what I could understand from this univariate plot. Okay, now I can actually go ahead and increase the number of variables that I'm actually analyzing. Let us say that I want to do the color coding on the petal width on the basis of the target value, which actually comes under the bivariate plot, but I want to show you here since we are talking about the single column in the data set and we see 3 clusters, right? So I wanted to see whether these clusters, 3 clusters, are belonging to the each variety that I have got in the data set. So just to validate that, I'm going to say sns.scatterplot. Here my data is my df. Okay, for x I'm going to consider, okay, df.index. Okay, let's see if it works. Okay, then I'll say y, I'll just mention it straight away in this way. Y is equal to sepal. Yeah, currently we are analyzing the petal width. Okay, now I'm going to say hue is equal to df target. Okay, now we would actually require the x as well. So just say index. Okay, so now if you observe the data, see, our guess was right. So each cluster that we see observe on the petal width, each cluster is actually referring to the individual target value in my given data set. So we can increase the number of variables that we are analyzing and get a better perspective about the data that we are analyzing. In this case, the data that I'm analyzing is on the column of petal width. Okay, so that is the usage of the scatter plot and the color coded plot whenever we are working with the classification data. Now, apart from this, there is another kind of plot which is known as the swarm plot. Now, the swarm plot that we have got, it is a visualization technique that we generally use it on a univariate data, and it would generally help us to view the spread of values in a continuous variable. Here, in case of swarm plot, here the swarm plot spreads out the data points of a variable automatically in order to avoid the overlap. And hence, when we are doing the univariate analysis, it actually gives us a better visualization about the data set. So the next plot that I'm going to create is a swarm plot. So sns dot swarm plot, and here x is equal to data is equal to df and x is equal to, okay, so this is how this swarm plot would look like. We can also say y to get the visualization if you prefer. See, this is how a swarm plot would look like. So it actually gives us an idea as how exactly the data is actually distributed. Now I can also go ahead and look into its data distribution by referring to another column as well. For example, I would say that my x is equal to target. Okay, so this is how my data would look like. See, this describes the data, okay, like for each class how the distribution of values would look like. Okay, so this is actually giving me a better view compared to what I had got in a scatter plot. So whenever there is an overlap, I'm unable to understand what exactly are those values. But here, since there is no overlap, it gives me a better perspective as how the data points are actually present. Okay, so this is how you can get a better understanding about the plot. And while creating the univariate plot, the another plot that we generally use is a histogram chart. So histogram chart is what we use it whenever we are working on a continuous data set. It gives us the information about the range of values and the relative frequencies of the values which are actually present in various intervals. So this histogram is also going to help us to understand the shape of the data set as well as the spread of a data. And remember, this histogram chart is also used for continuous data set. So in order to create a histogram chart, I'll say df. Okay, so I'm going to consider the petal width column itself for the demonstration purpose. So this is how the histogram chart for my petal width column would look like. Okay, so this is a visualization that we could get from the plot, and here these are all the various spinning values. Okay, the 41, 8, 1, 7, 8. So it actually describes the frequencies, like what is the frequencies that I've got in each pin. Now apart from that, there is another plot that is called as a density plot. Now the density plot is very similar to a histogram chart, but I would say it gives us a smoother version of a histogram chart. Generally, the KDE estimate, that is the kernel density estimate, is actually used in the density plot to show the probability density function of a variable. Okay, now in order to show you the same, I'm going to say df petal width column, and on top of this I'm going to specify the kind as density. See, this has created a density plot. So this would return me a continuous curve, which is a kernel that is drawn to generate a smooth density estimation of my entire data set. Okay, so this is how I can create a density plot. We also have an equivalent function in Seaborn library, which is known as sns.kde and using this function, you can also create a kernel density estimate plot. Okay, then see, apart from this, you also have something called as, the famous one, which is a box plot. Now box plot, I would say, is one of the very useful and a standardized way in order to display the distribution of the data set. And while displaying the distribution, it will display it in terms of 5 number summary. That means it describes the distribution about the data set with a 5-point summary. So when I say 5-point summary, it contains minimum value, Q1, Q2, Q3, and the maximum value. So by creating a box plot, it will help me to understand how the data is distributed, and it will also helpful in finding the outliers in a data set. In order to create a box plot, I can say plt.boxplot, and I can specify the column name, and this will help me to create a box plot that would look like this. Here, the upper and the bottom lines that you see right here, so these are called as a whiskers. Okay, these are called as the whiskers, and in the middle you see a box, and this line is called as a median. Okay, this is my Q1 and this is my Q3. Okay, and Q1 minus Q3 is called as the IQR. So you have learned this already in our previous learning journey, but I'm just specifying right here for you as well. And if I have any data points which are which are outside the region of whiskers, so we call these data points as an outlier. Now in my example, there are no outliers in the data set. In case if you have an outlier, you'll be able to visualize it whenever we create a box plot. To illustrate the same, let me create the visualization with the another column. So this time for creation of visualization, I'm going to consider the column of sepal width. Okay, so if you visualize the sepal width, so this is how the box plot would look like, and we can come to know that there are outliers in this given data. Now when we are working with the categorical data, so we have got variety of plot. So one such plot that we have got is the bar chart. Now bar chart is a plot which is going to help us to describe about the frequency, okay, of a categorical variable. So in order to create a box plot, I'm going to mention it in this way: df target value underscore count, and here on top of this I'm going to call the plot dot bar. So this is going to create a bar chart for me, which says that, okay, how many number of unique values that I have got. So if I do not want to manually call the value counts and call the bar plot, I can directly call the count plot like sns.countplot. Now using this sns.countplot function, I would say that data is equal to df and x is equal to target. So I can create a count plot in this way as well. Now apart from that, while working with the categorical data, so we also make use of the pie chart. So pie chart is one of the common way to visualize the numerical proportion which are occupied by each of the category. Now here I'll say plt.py, and inside the parenthesis I'm going to mention as df target value underscore counts. Okay, and we can specify the labels if I want. So I'll just execute it. See, this has created a basic pie chart for me. If I want to add the labels, I can add the labels, saying it as labels is equal to I would say iris target underscore names. Okay, so in this way I can get the labels as well. Okay, so what we have done as part of this video is we have seen the various ways in which we can visualize the univariate data. So when we talk about a univariate data, like I'll be analyzing each single column at a time. So we have seen as how you can analyze a single column at a time and what are the visual methods that we can employ in visualizing these data set depending on type of data it holds. So we have seen how we can visualize the continuous values. So first we have looked into the continuous values. So in case of continuous values, we've looked into the scatter plot, histogram chart, like this violin chart, KDE plot, box plot. So these are the various kinds of plot that we have seen in case of the continuous values. And then we have also seen the various ways in which we can visualize the categorical variables as well. Now I'll be sharing this code over here along with the video. I'll be linking the link. I'll be sharing the link in the description. So let me attach it over here, team. Okay, I've uploaded the file to your LMS. You'll be able to access it through the LMS by using the link that I have shared to you in the description. Do check out the link, and thank you again for watching till the end. I look forward to seeing you in the next video. So if you're new to our channel, consider checking out the playlist on statistics, and we also have a playlist on machine learning, which is a very active playlist. Do check out the same, and I look forward to seeing you next time.